Hello everyone, welcome to TryRide, the new era of learning. This is Pack 365. Let's move into the topic. Today's topic, we're discussing about uninformed search algorithm in AI. This is our module 2. Let's begin this topic and let's start the topic. So, uninformed search algorithm is also known as a blind search algorithm or a class of search algorithm that do not use any domain specific knowledge about the problem being solved, right? It also known as blind search, as usually. The terms highlights that those algorithm operates without any specific knowledge, like clues. Okay, so about the problem they are trying to solve, other than the problem definition itself, they did not have heuristic or estimated to close they how to close they are to a solutions like a class of a search algorithm. Those algorithms are fundamental techniques used in AI to navigate through a state space to find solutions. A state space can be true of a has possible configuration or situation in the problem. So, such algorithm. So, uninformed such algorithm relies on the information provided in the problem definitions, such as the initial state, action available in each state, and the goal state, right? So it usually through starts a start space it takes to find a solution. A state space can be through of as in possible all possible configurations and situations in a problem. So it goes to there is solutions, right? So like we put it, so they're all called blind because they don't know they do not have any heuristic function to guide the search towards the goal instant. They explored the search space systematically. Yes, they did not have any configurations like that. So they did not have estimated, heuristic or estimated of how close they are to a solutions, right? They are trying to solve the problems. They didn't have enough specific knowledge or clues in uninformed search algorithms, and uninformed search algorithms provide basic search strategy for exploring the problem space where no additional knowledge is available, right? So we can say that do not use using any specific knowledge about the problem being solved. This is a different characteristic, unlike informed search algorithm which use heuristic or domain-specific knowledge to guide their search. Okay, so when it comes to uninformed search algorithm, it explores the search space systematically without any intelligence guidance. They simply follow a predefined order. So those algorithms are important for solving a wide range of problems in AI, such as pathfinding, puzzle solving, and state space searching. So types of uninformed search algorithm. They are breadth first search algorithm, we call it BFS algorithm. So depth first all search algorithm, we call it DFS. And finally, iterative depending depth first search algorithm. Okay. So IDD-DFS. So first we all let's go into a few minutes for few topics. We put side about what is uninformed, right? So first we want to know before learning the DFS, BFS. First we want to know what is graph. We want to know the what is graph. Okay. So let's move to the what is graph. We all know that like this is the graph. No, it's only name itself graph, but actual relation of the graph is not that. So the graph is the title that's cross what is a graph? A set of fundamental definitions. Okay, so from here it shows the connections between. It shows the relations. It shows the pattern classification, finding the roots. It's connect with get together with each other, like it connects the system. Okay, so according to the perspective, the slides appear to be disclosing the concept of a graph in the content of computer science. Okay, so in discrete mathematics, which is often crucial for representing the problems in AI, like the search space for algorithm. Like okay, so the crossed out image, this is important too. It indicates that the presentation is not referring to be common kind of graph. You might see a math class, okay, or a news report like a bar chart, line charts, and or a pie charts that visualize the data. Okay, So the partially visible image a net graph. So this type of graphs that presentation likely refers in the computer science a graph or a data structure construct which has a nodes and edges, right? So we from the exploring the graph we have a data structure containing like a set of verticals V and a set of edges E, sometimes called nodes. Here we an edges and representativity connections between two verticals, right? With graph GVEG of VE, right? So it cross nodes is nothing but the individual points or entities in the image. Those are likely circle, okay, with what look to like person icon, like it looks the forward. So where verticals nodes is nothing but this is the nodes, and edges is nothing but the connections or a relationship between the nodes. Okay, it will maintain the relationship between the nodes by using traveling the path, like connecting the circles, both circles. So the graph it right, we can see that V of A, B, C, D have it. So jointing the edges, we have how many verticals we have nodes A, B, C, D, right? That. So how many edges we have? We can see the edges connection like A to C, A to C. We have B to C, B to D, and C to D, C to B. Like that, we have connections. We have okay, number of edges touching the given verticals A equal to 1, A how many 1, B how many 2, C how many 3, like that we have considered D how many 2. So, a graph example, for each graph, we can say that for each, what are the verticals and what are the edges, like web pages. We use mostly graph examples in web pages, web links, methods in the problem that calls the each other, random maps in Google Map, example like Google Maps, airline routes, we use graphs and Facebook friends and course requested and family trees and path through a maze. So we join the links between the like here we persons all we have connected these all verticals and where the connecting with edges. So like that we design a graph. So we want to understand what's the graph, what's its behavior. Then only we can easily identify and understand the BFF and BFS and DFS. So, what is a path? Path is nothing but it is a form of vertex. It's to join the. It is a sequence to join the connection between the relations, right? So, in sequence of starting that can be followed starting from the A to reach the B. Okay. So it's set a goal to reach its destination. Okay. So can be represented as vertical visit or edges taken. Example one path from V to Z. Like we can see the graph here. So one prof to V to Z, we can travel from V to Z. We can easily travel by VXZ, right? We can easily travel like that. But when it comes to V to the edge, it definitely it wants to travel like a loop. It form a loop. Like when it comes to U to Y, U to U, W, X, Y again W, again V. That like it forms a loop. Where are two paths are from U to V like that. So path length, number of verticals or edges contained in the path. It is path length, okay? So how many edges and contents in the number of verticals? So neighbor or adjacent we called as or both neighbor or adjacent we call them. So two verticals connected directly by an angle of edge, right? So we can see that V and X were whole jointed connections here. So real reachability and connectedness. So in a reachable is nothing but a vertex A is reachable, right? So from the B, if the path existed from A to B, if the path existed from A to B, like we have see that we can see that A to B like this. So connected, a graph is connected if very vertex is reachable from any other is the graph is the top connected, right? So in simple way we can say that like we have two example like this. So in computer science also or in AI graph, we usually use this representations graphs. Okay, so I should discuss in end about it first. How to complete this? So strongly connected like whenever vertices has edges right to every other vertex. So it has own joints, closed loops, we can say. So now the concept of loops and circles. Now we form the concept of loops and circles. So cycles here we can see that a pattern called a path that begins and end at the same node. Example, we can see it forms a loop here from BGFCA, right? We have the form a loop like B, we start with GFCA, it per outer loop, and from inner loop it considered V, X, W, U, V, Y, VX, W, sorry, VX, Y, W, U, V. Okay. For example, we can see another example too. Like we for outer loop, we can see CDA. Like it travels from U V X W like that. We can travel like that also like U W V U like its own decisions. Like we can see another point here. So it's when it travels the loop, it forms the loop here. Like it forms the loop here now. So in the second example, we can see that when it comes to the CDA, so it usually like inner loop will be traveled like W U W V U, right? U W V U. It returns to U again. So like the loop will be complete the path. It closed the path. Okay. Loop and cycle segment. Loop is like it's running outer loop. It comes to like when when it's reached to the starting point. It starts from the starting point. When it completes the loop and it comes to again starting point, it forms a loop, right? So it forms a closed circle. Like that, we form the closed circle, sorry, loop, and edges directly form a node to itself. Okay, so many graphs does not allow loops. Okay, because when we allow the loops, what it happens, we cannot recognize the value. We is stuck in one part. We cannot move forward again after that. So, like the structure will form. So, now move on to the next graph. So, next we have weighted graph. In weighted graph is nothing but it is a cost associated with the given edges, right? So, some graphs have weightages, some are unweighted. Depends on the value. Edges in an unweighted graph can be true of as having equal weight, right? All zero or all one. Okay. Only we can have edges in an unweighted, like we have only one. We have multiple edges, right? For the vertical. And most graphs do not allow negative overweight. As most graphs doesn't allow negative weight because it rarely happens when it weighted. Not only in weighted graphs, in any graphs, in mostly when it comes to reinforcement like dysentery, except that some graphs doesn't allow negative values. So negative weighted. And example graphs of airline flight weighted by the miles between the cities. Like it is one of the airline flight graph. So we can see here we have P or DLA Las Vegas. We have some kinds of airline flights. So in 1890, it is a miles difference of 1843 miles from away from ORD. Like we can see the proper identification of the weighted graph, how the letter here we can have route map from the if we start from the starting point as PVD, we can directly start from PVD and we our destination is HNL. We have routes like we want to reach ORD or SF, and then we can reach the HNL. This is a one-way route, but actually here we have a trouble because after reaching a SFO, we does not have route to the HNL directly. So we move. We used to move that. So usually we used to move the LAX, then we can HNL. And we have another direct, like we directly move to LGA, then we can short distance, we can take the short direction, like by traveling the circle here, we can take the short direction of LGA, loop, DFW, and then LAX, then HNL. Like then we can travel. So from the next part, we have directed graph. In directed graph, we can see here. So a directly graph one where edges or one-way connections directly connection to each other. Each and every vertical has each direct connection to the one specific vertical like we can call it as. So if graph is directly a vertical has a separated in out degree. Okay. So a graph can be weighted or unweighted. Is the graph below connected? Why or why not? So if we can see that in a vertical in a directed graph, the graph should be connected, right? And because why it's connected means when verticals. when just with directly connected to each other. So when easily we can move we easily perform some steps to moving the forward to another graph. It is helpful for that. While moving from the other state, from one state to another state, if the graph is connected below to the each graph, then we can easily uh, transform to one vertical to another vertical. Like one node to we can travel another node from there to another node if the edges are connected. So this is useful in this is why this is useful in directed graph. We have a final concept of what is linked list trees and graphs. So we all know about the binary trees, a graph with some graph structure. In machine learning, we all know about the decision-making tree, which is a tree-based structure, and random forest to multiple trees. And the tree is an unweighted directly um, actually graph. Okay, so each node in degree at most of one and out degree at it most of two. Those is exactly one path from the root to every node. So nothing but a tree graph is we are designing tree graph has a statement based, like we have some set of data set. From the data set we exploring some kind of data to arrange in a proper manner, like we have the raw extracted raw data we extracting from the raw data, and we visualizing the data into tree based structure. So which in the use in the proper manner. Okay, like that when the treatment of like the when we use like in such cases we can say that in machine learning models in most of the concept we use that method. Okay, when it comes to linked list, unweighted drag like in and out degree with almost one from the all nodes, like linked list method, it doesn't have multiple connections. Linked list only connect to one another to one another. It may be sometimes it may be connect to one is to another. Okay, like if A is B, B is to C, C is to D. Like it usually connected, so it forming a series. Okay. In such cases, linked list also can be connect both self. Okay, it has a self connection too. I hope you guys you understand about the topic of what is graph and the uninformed search. Right. Thank you all of you.